on the video screen. Images bright, flowing an endless stream. Bits of information, logic, black and white. Bits and bytes of information, turning darkness to light.
Hello, welcome to Bits and Bytes. In this episode, we're going to analyze what a computer program is, what its basic elements are. We're going to also look at the basic elements of the computer itself and see how these tie in with programming. We'll start by getting Billy Van to write a very simple program.
Okay, how do I do that?
Tell the computer to print your name.
All right. What's that little zero? What does that mean?
Oh, it's just that you're not making things clear enough for the computer. You have to put in quotes around Billy Van, making it quite clear that you literally want that name to be printed.
Okay, I'll try it again.
Oh, hold on a second. You don't have to type the whole thing all over again. We can do some editing with the cursor, that little flashing square.
Oh, that's what they call that. Uh-huh.
You can move it around and correct mistakes by pressing one of the cursor keys, the ones with the arrows on the right.
Oh, here we are. Well, it goes down. How do you make it go up?
Press the shift key.
Oh, there we go. And right. Shift key. Let's go left. I got it.
Okay. Now move the cursor to the first letter of Billy Van, retype it in quotes, and then press return.
Okay. Quotes. B-I-L-L-Y B-A-N. Quotes. Return. Have I just written a program?
No, not yet. What you've written is called a direct command.
Well, what's the difference between a direct command and a program?
A direct command is a one-time only instruction. You command the computer to print your name, and it does. But once it's done that, in a sense, it throws your command away. A program, on the other hand, is a sequence of commands that the computer does not throw away. A program is stored by the computer so that the next time you want your commands to be obeyed, you don't have to type them all over again. You just type run and the program runs.
All right, then how would I change my direct command into a program?
Well, with most of these micros, a command can only be stored if it has a number. Otherwise, the computer will lose track of where it's put that command.
Okay, then I'll give my command a number. The number 1. Okay. Return. Oh, wait a minute, it didn't obey me.
And it won't until you type run.
Oh, R-U-N. Hey, I see.
Congratulations! You have written your first computer program.
Do you mean to tell me that this first line is a complete program?
Yes. Now, it's probably the world's shortest program, but it is a complete program.
Well, you have to admit, not too bad for a beginner.
Mm-hmm.
But it seems to take so long to tell a computer how to print my name. I mean, I could print it faster myself.
Ah, but how many times could you type your name before you got tired? See, the computer never gets tired, and it could go on printing your name forever.
Oh, how do I do that?
Just add one more line to your program.
Okay, line 2.
Tell the computer to go to line 1 by typing go to 1, and type go to as one word.
Okay, O-T-O, 2, 1, return.
Now type run.
U-N. Oh, wait a minute. What's going on here? It's going crazy.
It's printing your name over and over again.
It doesn't look like that to me.
That's because the words are scrolling up the screen very, very, very quickly.
But how did my program make it do that?
Well, let's have another look at your program and you'll see.
I'd love to, but where is it?
To find it, you'll have to first stop the computer printing out your name. Press the key marked stop.
Okay.
Now clear the screen by holding the Shift key down and press the key marked CLR for clear.
Right. Shift. Clear.
And now ask the computer to show you a list of your instructions in your program. Type LIST.
There it is.
And this is how it works. The computer reads line 1, which tells it to print your name. It then drops down to line 2, which tells it to go to line 1. Line 1 tells it to print your name, and as you can see, it gets caught in an endless loop.
Well, actually, it seems very simple when you explain it.
Yes, it is, isn't it? You know, computers are so simple-minded that people often have difficulty with them. It's hard to think down to their level.
The computer is rather like a little office which has two hatches. You feed information and instructions into the office through the input hatch, and the results of your instructions are dished out to you at the output hatch. Inside the office is a very literal-minded clerk who can only carry out one very simple instruction at a time. He is called Central Processing Unit, or CPU for short. CPU has access to two little boxes. One is called ROM, which stands for read-only memory, and is filled with permanent instructions on how to do his office work. And the other is called RAM, which stands for random access memory. And this is where CPU holds whatever information or instructions that you care to give him from time to time. For example, some instructions like this, CPU will put straight into his RAM box and then go away and mark time until you give him the command run. CPU will then return to the RAM box and read the first instruction, which tells him to print something. CPU promptly nips across to his ROM box and looks up how to print. Then he prints something and gives it to you at the output hatch. Next, CPU trots over to his RAM box again and reads the next instruction, which contains the command go to. Back to the ROM box to find out how to go to, then go to instruction number 1 in the RAM box, which tells CPU to print something. Then it's over to the ROM box to find out how to print, because CPU has forgotten already. Then he prints something and gives it to you at the output hatch. Then back to the RAM box to read the next instruction, which contains the order go to. Of course, he's forgotten that, so over to the ROM box to find out how to go to. Then go to instruction number 1 in the RAM box, which tells CPU to print something. Then back again to the ROM box to find out how to print, and so on and so on and so on. The only thing that keeps this dim-witted little bureaucracy in business is that CPU moves with lightning speed. So fast, in fact, that he can give you the illusion that you're dealing with a very clever outfit indeed. You no sooner ask for something than it's done. The naive reality behind this illusion is hidden from you, because all that this office consists of is CPU and his two memory boxes, ROM and RAM, and the input and output hatches. And that's all that any computer consists of. And even this can be reduced to 3 basic elements when you come right down to it: input, output, CPU, and memory.
Let's see, input, output, CPU, and memory. You know, it all seems pretty simple.
It's simple, but it's also very powerful. With those 3 basic elements, the computer can do a lot of different things. And up to this point, we've only seen how it repeats information. But it could carry on a sort of dialogue with you if you like. Why don't you load that disk beside the pet, and you'll see.
Okay.
Now type deload for disk load. And the name of the program, word hunt. Type a quote sign and then word hunt, all one word.
Okay, quote. key, return. And now I type run. Do you want instructions? Yes, please. A group of hungry agents known as the word hunters is listing your aid in the following manner. A tribe of important words have been reported missing from the vocabularies of many students. Your mission, you will be required to discover the correct words from clues given on the wanted poster and add them to your own vocabulary. Press return to continue. Okie dokie. Your efforts will be rated accordingly. Good luck, thank you. Wanted, adjective alias eager, last known meaning wishing very much. Can you identify this word? Yeah, I think I can. That would be, good, what is it? Want. Oh, I'm afraid not. Do for that one. Description, 2 syllables. 2 syllables, eager, eager, eager.
Try the word anxious.
That might work. Okay. Thank you. Okay, we'll try another. I wanted a noun, alias glen, last known meaning low land between a hill. Glen, valley. Let's try that. Yes, I think I know it. V-A-L-L-E-Y. Terrific. I got it. That was pretty good. But how was that program actually written?
Call up the listing and you'll see. Press the run stop key and then type list.
Okay. Stop. And L-I-S-T. Return. Whoa, look at that. Tell me, why do the lines go up in tens instead of 1, 2, 3, 4?
Well, when you've written a complicated program, you may not get it right the first time. So you leave spaces in the program by making the line numbers go up in tens. And that way, if you need to, there's room to insert new statements.
Well, that's a good idea. But you know, I'd have to be a computer expert to write an elaborate program like this.
Yes, that program would take some experience to write. But you know, you'd be surprised at the different types and ages of people getting involved in computer programming these days.
I was about 16 or 17 when I was first introduced to computers.
I'm 73.
I'm going to be 8 next month, August 13th, right after my mom's.
I got started late, 9th grade.
64. and a half. Computer Town is a number of things. Mostly it's a spirit.
There's a Computer Town site anywhere that people have set one up. They're in libraries, in public schools, in community centers, in recreation centers.
It's grassroots in that it's community-based.
I think there are about 40 Computer Town sites in the United States and about 40 in Great Britain, and then in a few other countries in Europe.
It's providing access to equipment and know-how for anyone.
Our youngest classes are for 7-year-olds to 9-year-olds, and then we teach up to 12-year-old. Anybody who's over 12 is an adult. I have 80-year-olds in my class, middle-aged, young, just about the whole spectrum. Anybody who's capable of sitting up at a computer can take one of our classes. The type of person who generally takes our classes is not scientific. The most common in the adult classes will be housewives, then businessmen who want to know about computer systems. They're thinking about getting them for their offices. Then elderly retired people who just want to keep up with what's going on. And then a few younger students in the high school age who want to go beyond what they're learning in high school. Generally, we keep everything on a non-mathematical level, usually dealing with words rather than numbers. And I think people find it not too difficult and a lot of fun. I mean, we are oriented to going at their pace.
I took the course initially because I work with children in the school system who have learning disabilities. And I thought that getting them involved with something as challenging and interesting as a computer might help expedite their learning.
I work at a bookstore that has just gone on the computer, and we've had lots of problems with it, and I think that the people that use it don't thoroughly understand what they're doing. And so I thought it would be a lot better if I got some instruction. And it has helped already.
I think that we will get to the point where everybody will know how to use a computer just like they know how to jump on and ride a bicycle. It'll become a part of daily life.
Well, I think it's a lot easier for the kids than it is for the older people. They pick it up so much faster than we do, and I think that's interesting.
The adults are intimidated by this machine at the first class. They want to know what happens before they hit that enter or return button. They don't quite understand how it's all working at first, and they want to know. The young children usually are students themselves. They won't wait for you to tell them to turn the machine on. They will immediately begin exploring it and hitting the keys and the buttons. They won't ask what happens before they try it. They'll just do it. They're quite fearless.
I'm just learning how to program. They have these little, like, microchips in them.
It's really neat to see the seniors working with the computers. In a sense, the seniors are more like the kids than they are like their grown-up children. The seniors are old enough to forget about what it feels like to be a fool. They're willing to be fools, and they get in there and they try things.
As far as I know, we are the only place in the United States, which probably means the world, where there's a class of computer teaching or computer understanding for senior citizens. We started this class with the idea of really not so much teaching senior citizens to learn how to be computer programmers as continue to think, continued learning. I firmly believe that the closest thing we'll ever get to the fountain of youth is keeping your mind alive, continued learning. I think the main things is the enthusiasm that I see from the students from learning computers, realizing it is something they can learn and something they can conquer, and it's really not a mysterious device. It can become a very useful friend that will do much to make their life easier and more pleasant.
I started when Matt came here and sat down and started poking around and found out that it was a lot of fun. So I got involved and learned a little bit, not very much, but just kept plugging along. And now I know enough to teach other people who don't know anything.
Once you've pressed the key and found out the machine doesn't bite, that's the first step. It's kind of like opening a book for the first time. In a sense, I see Computer Town growing and blossoming because it's very important for people to master the computer and make it a human tool. In another sense, I think that Computer Town's future is doomed because it's a special purpose activity. It's like, what would happen if we had Pencil Town? You don't hear about a Pencil Town or Pencil Town movement which is designed to make people pencil literate. Our society's moved past that. And I think that we will move past becoming computer literate because every child will grow up with computers and we won't need that. But right now, it's in a tremendously important growth stage. There's no way not to be working with people and computers and not be a computer town. It's a catchy name for what we hope is a global effort to include everyone in this information technology.
You know, that's very encouraging, but I don't think I'd ever be able to write anything like that word hunt program.
You'd be surprised, you know. You could write a little quiz program right now if you like.
Yeah, I'd like to try.
Okay. Before you start a new program, you must get rid of the old one. Otherwise, the computer will get all confused.
Oh. Okay, well, I'll just turn the computer off then on again.
You could, but there's a better way. You can simply tell the computer to get ready for a new program. Type new, and that will wipe everything out of its random access memory.
Okay. EW.
Now clear the screen.
Clear.
Good. Let's try a simple history quiz. Say that consists of just one question. For instance, ask the computer to print out an important date.
Important date. Let's see. All right. What year was Confederation in Canada? Shall I type that?
Good, fine. But you could make it even shorter. Tell the computer to print, when was Canada born?
Okay, let's see. I'll start with 1. No, 10 would be better, wouldn't it?
Good.
Okay. Quote, when was Canada born? And be question mark, quotation. There.
Now you have to type a new line with an instruction telling the computer to wait for the student to input an answer. And you do that by typing input.
Okay, now let's see, that'd be line 20. Input.
And then answer.
Yes, but we don't know what the answer's going to be.
True. So just type any letter which can stand for any possible answer.
Okay, A for answer.
Good. Now we want the computer to look at whatever answer has been typed in and decide what to do with it.
Oh, but there could be thousands of answers to this one.
We can arrange things so that the computer only has to take care of 3 possibilities. The correct date, a date that's too early, or a date that's too late.
That's logical.
Well, it's a logical machine after all. Let's make your next line deal with an answer that's too early. And for this, you're going to need the symbol that stands for is less than. It looks like a V on its side pointing to the left.
Oh, here it is right here.
Now type 30. If A, for answer, is less than 1867...
Okay, line 30. If A is less than 1867...
Then print...
Then print...
Then some reply from the computer, telling the student that the date typed in is too early. Just the word early. In quotes with an exclamation mark will do.
Quotation, E-R-L-Y, exclamation point. Ah, what now?
You need to tell the computer to wait for another answer from the student.
Oh, well then I type input A again.
Now remember, you've already got that. So, just send the computer back to line 20. Type a colon to show that a new instruction is coming up.
Okay, colon.
And then go to 20.
Go to 20. There we are.
Let's review what we've done so far. Line 10 tells the computer to print the question. The computer then goes to line 20 that tells it to wait for an answer. Next, it goes to line 30, which tells it that if the answer is less than 1867, then it must print early and go back to line 20 to wait for another answer.
Wait a minute. What if the answer is not less than 1867?
In that case, it automatically drops down to the next line.
Which is?
An instruction telling the computer that if the answer is greater than 1867, then it must print, let's say, late, and go to line 20 again to wait for another answer.
Okay. Wait a minute. Don't tell me. The sign for is greater than is a V on its side pointing to the right?
That's it.
Okay. I think I can handle line 40 all on my own. Line 40. If A is greater than 1867, then print quotation late exclamation point quotation.
Don't forget the colon.
Don't forget the colon. There we are. And go to 20.
That is terrific.
Oh. Yeah, but my program isn't finished yet, is it?
Not quite. There's the third possibility. You must tell the computer what to do if the student gets the correct answer.
Okay, that'd be line 50. If A equals 1867, then print very good?
Well, you could type all that, but remember we've eliminated all the answers that are too early or too late. There's no if about it. The computer can only get to line 50 when the answer equals exactly 1867. Just type print, very good, in quotes.
Okay. Print, quote, very good, quote.
That's the end of your history quiz.
Shall I run it?
It's all yours.
Okay. R-U-N. Okay, now here we go. When was Canada born? Okay, computer, we're going to put you to the test here. Let's say 1492. Early. Yes. Let's try 1969. Late. Right. Now let's try, 1976 is late. And now we'll see. 1867. Very good. It worked. You know, it's as if the computer understood my wrong answers.
Yes, but of course, that's an illusion. The computer understands nothing. You must spell out every tiny step.
If you ran out of milk, all you'd have to say to even quite a young child is, please fetch me some milk. Give them the right change, and sooner or later you'd get your milk. But if you had to get a computer to run errands for you, it would be a different story. Unlike the little boy, it wouldn't know where to find milk. So first of all, you'd have to tell it to go to the nearest corner store. But of course, it wouldn't know what to do when it got there. So then you'd have to tell it to look for the milk in order to be able to answer the question, is there any milk in the store? But even if the answer were yes, the computer still wouldn't know what to do next. You would have to tell it to buy some of this milk and bring it home. And if the answer to the question, is there any milk in the store, were no, you'd have to tell the computer to go to another store and look for the milk in order to answer the question, is there any milk in the store? If yes, buy some and bring it home. If no, go to another store, etc., etc. If there happened to be a shortage of milk in your neighborhood, the computer could find itself caught in an endless loop, going from store to store ad infinitum. This is the first basic operation performed by a computer program, repetition. And here is the second basic operation performed by a computer program, yes, no decision. The inner workings of all computer programs, however complicated they may appear on the surface, are all variations on these two basic themes, repetition and decision.
So that's how computer programs work.
Yes, they aren't really so difficult, are they?
Let me think. Now, maybe I could elaborate on my program. Now, let's see. If the date...
And while Billy is polishing up his program, let's see what's coming up in our next episode, which is about what a database is and how it works.
When a large collection of data is organized systematically, it is called a database. In other words, a database is a filing system.
Storing information in the computer. We'll look at how a disk is formatted.
It usually consists of dividing the disk into a number of tracks.
Until then, I'm Luba Goy for Bits and Bytes.
Oh yeah, I'm Billy Van, and I'll see you next time. This is starting to work. It's great.